Moving 12 tons of solid steel may sound like a job for brute force, but it is actually a delicate business. Getting this big blue turbine inside this small gray building will require 2 cranes, lots of planning, specialized lifting gear, assorted cutting tools, and some elbow grease.
This piece of equipment is one of the heaviest pieces. It weighs a little bit less than 12 tons, which is our ultimate capacity of the inside crane. To put it in and place it, we are actually going to use 2 cranes and spin it until we place it.
The turbine is being installed as part of Metro Vancouver's Seymour Capilano water utility project, providing cost savings by harvesting the energy available from the water returning to the Capilano Reservoir from the Seymour Capilano Filtration Plant. Because the Seymour Capilano Filtration Plant is higher in elevation than the Capilano Reservoir, excess pressure will be generated when treated water is returned to Capilano for distribution. This water pressure will spin the turbine, generating electricity that can partially offset the power requirements of the pump station.
The power of the generator is almost 1.7 megawatts, and according to the flows that we've seen historically, we're expecting to see 9.6 gigawatt hours of electricity produced every year.
9.6 gigawatt hours of energy is roughly the same amount of electricity that 1,000 homes would consume in a year.
It can cover the consumption for heating, electricity, and other base consumption of both Capilano Pump Station and Energy Recovery Facility, or it can cover a bit more than what one pump uses down at the Capilano Pump Station.
But first, this 12-ton piece of custom-built equipment must be moved into its permanent home. While one operator controls the crane's movements, another worker, called the slinger, directs, watching carefully as the big box containing the turbine is moved from the truck and lowered into position for its final move into the building. The turbine is lowered onto a set of steel skates. These wheeled plates support the box and allow it to roll along the beams put in place to bridge the opening in the wall. 2 cranes are required for the final stage: the truck crane outside and an overhead crane inside the building. It's a delicate operation with no room for error. Finally, the turbine is lowered into its final position and bolted into place.
Once all the pieces are installed, we are going to do dry commissioning. After that, we're probably going to use 1 or 2 pumps from the pump station to do partial wet commissioning. And then once the treated water tunnel is in service, we are planning to do a full commissioning.
The project is scheduled for completion by mid-2015.